Dear learners, today I will be talking about volcanoes, which is a part of MEV 002. I introduce myself as Professor Baskar from Guru Jambheshwar University of Science and Technology, Hisar. After listening to this unit, you should be able to define the term volcanoes, describe the various volcanic eruption processes, understand the hazards associated with volcanic eruptions, and list the prediction methods for the volcanic hazards. Volcanoes are one of the most dynamic geological features present on the earth. The origin of the word volcano comes from the Greek word Vulcan, which means god of fire. In simple words, a volcano is an opening on the earth's surface through which hot molten material escapes from its deep interior. Volcanoes help in understanding about Earth's interior because some material comes from the interior of the Earth. They give us the information about the interior of the Earth. They emit magma and gases, bring out molten material from inside the Earth to the Earth's surface. They change the Earth's landscape. Emissions from volcanoes during early Earth history have played a significant role in the origin of the atmosphere. They are responsible for all the oceans and mountains which are formed. They will continue to do this. Magma composition can be felsic or mafic. Felsic magma are more viscous, volatile rich compared to the magma which is mafic, which has less silica. They erupt explosively when compared to the mafic magmas. Study of volcanoes is called volcanology, and the persons who do it, the scientists who study the volcanoes, are called volcanologists. Some terminology we have to understand before proceeding ahead. I have given a definition of volcano. Again, we can see what is this. Volcano, any landform that releases lava, gas or ashes or has done so in the past. A volcano is a vent and its surrounding accumulation of volcanic material which connects a pool of molten rock material, that is magma, below the earth's surface with the surface. In other words, it connects the subsurface to the surface through the magmatic material. Pyroclastic material, when we use this term, this includes all solid material that are ejected from the volcano. Now, we should know the parts of a volcano before we proceed further. For example, what is vent? It is a pipe-like conduit connecting the magma chamber to the surface. And what is a crater? You can see the diagram here. It is a depression or bowl-shaped formation at the summit of a volcano. It is connected by a vent or pipe to the magma chamber. You can see there are secondary vents at the flanks of the volcano in the diagram. They are called fumaroles. Fumaroles are secondary vents on the flank of volcano which emit steam and other gases. I introduced the term magma chamber in the earlier slide. Magma chamber is a reservoir of magma in the earth's crust where magma may reside temporarily on its way from upper mantle to the earth's surface. Now, we have different ways to classify volcanoes. The first one we can see is on the basis of frequency of volcanic eruption. Active volcanoes can erupt at any time. Example is Hawaiian volcanoes. Dormant volcanoes are those which have not been known to erupt for a long time but could erupt any time in the future. For example, we have Mount Apo from Philippines. Extinct volcanoes means they have not erupted since historic time. An extinct volcano is one which has been dormant for more than 10,000 years. An example is Mount Kenya, Kenya. Now, we also have the classification on the basis of morphology. We have the shield volcanoes, the lava domes, etc. You can see the shield volcanoes are characterized by broad, flattened dome-like shape with convex side up. Thus, they are low, rounded profiles These are formed almost entirely of mafic lava flows. Lava domes, they are also known as volcanic domes. They are viscous, bulbous masses of lava dominantly consisting of felsic magma. These form steep sided mountains. You can see that the shield is almost flat and the lava domes are steep sided mountains. Then we have, on the basis of morphology, another classification which is called caldera. When the volcanism is so explosive that the top of the volcano is blown off and only little material builds up near the vent, then the underlying magma chamber is partly or entirely removed. It further sinks or collapses under its own weight with time. This results in creation of a huge crater-like depression which is called caldera. Normally it is circular and it is several kilometers in diameter. It dominantly comprises the rhyolitic magma. Then there is another classification, cinder cone. These volcanoes comprise particles resembling cinders which form when pyroclastic materials that accumulate around the volcanic vent. These are small and rarely exceed 400-meter height and are steep-sided conical hills. You can see the cinder cones are small ones and caldera can be several kilometers in diameter. Then there is another classification of volcanoes based on tectonic settings. If you see the diagram which is shown, there is hot spot, there is divergent plate and there is subduction plate or convergent margins. So they are called subduction volcano. These occur on the continental margins or island arcs along subduction zones where the edge of one plate thrusts beneath another plate. So these essentially occur in subduction zones. They comprise 80% of the active volcanoes. They are the most explosive and destructive. Circum-Pacific Ring is one of the example. We have the Ring of Fire. Then Mount Pinatubo in Philippines is one of those active volcanoes. Then we have other tectonic setting, rift settings. These are normally less explosive and occurs along divergent plate boundaries, particularly on the ocean floor. And a good example of this is the African Rift Valley. Then we have hotspot volcano. They are not related to tectonic plates and can occur at great distance from the plate boundaries. And they form above hot mantle plumes, upwellings, which rise due to convective process operating within the Earth's mantle. These can occur both in oceanic as well as continental regions. Examples are volcanoes of Hawaii and Yellowstone in USA. Then classification is also done on volcanic eruption style. Explosive and effusive nature of volcanic eruption depends on magma flow and amount of gas. It is called explosive when it is gas driven eruptions, are explosive which propel the magma and tephra. Large amounts of water and carbon dioxide are dissolved in the magma. They are characterized by voluminous lava flow and the magma is sticky, that is less fluid with lot of gases. Extreme violent eruptions eject pyroclastic materials. So you can see explosive style has large amount of water and gases dissolved. The second one is the effusive type. They form quiet emissions of lava. The eruptions are characterized by lava outpouring without significant explosion, lesser quantities of gases and more fluid. Then can we measure the volcanic eruption, can we quantify them? There is a terminology which is called Volcano Explosivity Index, VEI, which is used to measure the strength of volcanic eruption, which is a simple descriptive index ranging from 0 to 8. That means we can classify the volcanic eruption on this VEI, that is Volcano Explosivity Index. What is taken into account here is the volume of material erupted with the height of the eruption of the plume and the duration of eruption are considered irrespective of the fatalities and property damage. We do not consider the property damage or fatalities, but we take into account the volume of material, height of the plume and duration of eruption to arrive at this index. Now, what are the causes of volcanism? What is the one which drives these magma from the interior to the surface? It's the plate tectonics. Movement of the plate actually causes the earthquake and volcanism. Deep inside the earth, various radioactive substances generate lot of heat and therefore magma is in constant flux. This is under high pressure and the various gases create outward pressure. So essentially it is the radioactive heat which results in melting of the rocks. This, when combined with the friction of the moving tectonic plate and even the crust of the earth, results in rising of magma from the mantle to the earth's surface, causing volcanic eruption. So essentially the plate tectonics is responsible for this. If you see the products of the volcanic eruption, what is the material coming out of it? It can be solid, it can be liquid or it can be gas. Solid material of different sizes is ejected out of volcano during eruptions. They are known as pyroclastic material. They are different terms: volcanic bombs, lapilli or cinder, volcanic ash or volcanic dust. These depend on the size and shape of the particles. Then there is liquid material coming out during volcanic eruptions. Magma is the molten rock material consisting of mineral melt. Then there are gases which come out. Volcanic gases samples contain water, carbon dioxide, sulfur dioxide, hydrogen sulfide, carbon monoxide, hydrogen, methane, chlorine and argon. Now, what are the factors which control the volcanic eruption? It is the magma composition, temperature and viscosity which play an important role. What is viscosity? We know that it is resistance to flow. It depends on the composition of the magma and its temperature. Magmas with large Si content have great viscosity than magma with less Si contents. For example, granitic magma is more viscous than basaltic magma. Shapes of volcano depend on viscosity of the magma. For example, basaltic magma or lava form flat shield volcanoes. The characteristics of the magma also control the kind of eruption that occur, whether it is a felsic magma or it is a mafic magma. The volatile content, as you have seen earlier, is controls the explosive nature of the eruption. Then there is magma temperature. Different magmas are characterized by different temperatures and they also control the volcanic eruptions. Now, what are the hazards associated with volcanoes? Just like any hazard, you have primary, secondary and tertiary hazards associated with volcanoes. Primary volcanic hazards: lava flows are usually not dangerous. They move slowly and can damage property. There can be violent eruptions and pyroclastic activity. They are the most dangerous as they travel rapidly. Hot pyroclastic flow result in suffocation and because of the heat they cause burn and death. Then there can be ash falls. These are characterized by mud ash and gases. Then there is new ardente. They are fast moving flows of gas and magma in a volcanic avalanche. Then there is gas emissions. They accompany every volcano. Some of the gases include hydrogen chloride, hydrogen sulfide, hydrogen fluoride and carbon dioxide. Now there are also secondary and tertiary volcanic hazards which are associated. Lahars. Lahars are nothing but the volcanic mud flows resulting from the eruption under ice and snow at summit, which mixes with ash to make fast flowing mud. So the ice and snow melts and this becomes a fast flowing mud. Then we have tephra falls, emit huge quantities of loose unconsolidated tephra that are deposited on the landscape. They can devastate vegetation, crops and kill livestock. Then you have debris avalanches and debris flows. Volcanic mountains can steepen over time. Such steep slopes may become unstable. It can result in sudden slope failures, resulting in landslides or debris avalanches. Now, there are again some more secondary and tertiary volcanic hazards. For example, atmospheric effects. The volcanic ash which is released from the volcano can cause reflection of solar radiation, which results in cooler temperatures for several years after a large eruption. For example, the eruption of Tambora in Indonesia in 1813 was the largest recorded in industry. This year was called the year without summer. Volcanic gases like carbon dioxide are greenhouse gases that retain heat in the atmosphere. So you can see volcanic eruption can cause some effects in the climate variations. Then there is famine and disease, widespread damage to crop when it occurs because of volcanic eruption and livestock are damaged, they can cause famine and disease. Then there are other issues like flooding. Drainage systems can become blocked by deposition of lava flows. Volcanoes in cold climate can melt snow and glacial ice to cause floods. So you can have these kind of floods which are caused due to this. Then volcanoes can also cause tsunami. In 1883, eruptions of Krakatau volcano triggered several tsunamis, killed about 36,400 people. Tsunami is caused when a wave is generated in the oceans either by the earthquake or volcanic eruption. Volcanic earthquakes, even when volcano comes, earthquakes are usually precede and accompany volcanic eruptions. They normally occur together also. What is the method to predict the volcanic eruptions? Most volcanic predictions are based on various phenomena. It depends on the behavior of volcano. Every volcano has a unique character and it depends on the earthquake activity. It depends on the tracking the ascent of the magma. It also shows the deformation of the ground surface, and prediction is also based in change in gas chemistry and temperature of the magma. Now, what are the long-term prediction methods? Long-term prediction methods means we have to understand the geological history of a volcano, frequency at which these hazards occurred in the past. You have to examine the lava flows, other deposits of various eruptions which help understand the past nature of a volcano, and you can prepare a map showing vulnerable areas. Now, there are short-term predictions involves the monitoring the volcano to determine when the magma is nearing the surface. Monitoring for precursor events that likely signal a likely eruption. For example, we can monitor the seismic waves. Seismic waves are generated by both earthquake and explosions. S waves, as we know, cannot pass through liquids. So an array of seismograph can be placed around a volcano and small explosions can be set off to generate seismic waves. In case a magma body exists beneath the volcano, then there will be a zone where no S wave will arrive. S wave, this is called S wave shadow zone, because this is liquid and the S waves cannot pass through liquid. This can help recognize the position as well as the movement of the magma body which is occurring. Then as the magma moves and deforms rock, it may generate earthquakes. There is usually an increase in seismic activity prior to a volcanic eruption. Then there is volcanic tremor, indication magma is moving below the surface. Then there can be changes in geophysical signatures. For example, rocks contain minerals which are magnetic, for example magnetite, that can generate magnetic field. We know that above the Curie temperature, these minerals show no magnetism. If a magma body enters a volcano, the body itself will show no magnetism. If it heats the surrounding rocks to a temperature greater than Curie temperature, then the magnetic field over the volcano will be reduced. Measuring these changes in magnetic field, the movement of the magma can be tracked. So it is a very useful technique to know that some hot material is coming from below. Then there is changes in the groundwater system. As the magma enters a volcano, it may cause changes in the groundwater system. Water table may rise or fall, and because the magma is hot, the temperature of the water may increase. There is also change in the chemistry of the gases. The composition of the gases emitted from the volcanic vent changes in chemistry from the initial phase to the last phase before the final eruption. No single event can be used to predict a volcanic eruption. Many events are usually monitored and examined in totality. Now, there are several natural service functions of volcanoes. For example, they are responsible for outgassing of the earth to produce both the atmosphere and hydrosphere. Whatever we are having, the atmosphere and hydrosphere, this was a result of the volcanic eruption. When the early volcanic eruption in the early earth took place, the whole atmosphere was formed due to this. But let me make it to you clear, to you listeners, that oxygen which is now seen today is because of cyanobacteria due to the photosynthetic process. Earlier atmosphere, the early earth atmosphere had carbon dioxide, methane, ammonia, etc. So you can see this was responsible for building both the atmosphere and hydrosphere because water vapor was released. Volcanism renews the soil. The lavas produce fertile soil after weathering being derived from virgin materials, that is soils in the lava, and for example you can see black soils in central and south India. So when you have fresh volcanic eruption, normally you have the fertile soil. Then the volcanism is also associated with precious and semi-precious stones. That is, for example, you can see diamonds are found in India and South Africa. Then there are many ores, mineral deposits extensively produced by volcanism. Then the heat rising around magma bodies can be used to produce geothermal energy. This is a free energy which is given by nature. If we can tap it, the heat which is coming, we can use this, and this is non-fossil energy, and it is carbon neutral, and it is you can use it for several thousand years. And then you have crater lakes. Crater lake produce fresh source of fresh water. For example, Buldhana Lake in Maharashtra. Then they also provide abundant local source of material for landscaping, construction activities and road building. Whatever materials are required are taken from the earth, and these are formed by volcanic processes. So you can see, so in summary, learners, what we have understood is we have studied about the volcanic eruption process, we have studied about the structure of volcanoes, their types based on different classification, the effects of volcanoes, the impacts of the volcanoes, and how to forecast the volcanic events on certain precursor events. Now they also lead to the formation of new rocks and fertile soils. Obviously, for a geologist, they are natural scientific labs where extensive studies can be done for understanding the interior of the earth and for other geological studies. Thank you very much, learners, for patient listening.